All right, here we are, day 10 of 100 days of code. Whoop, whoop. So today I'm going to be going through binary trees. I started doing it yesterday, but I was pretty tired. So just got some of the setup stuff in there. Hopefully I'll be able to make it through breadth first search, depth first search. Got to start with breadth first search. We've got a pretty good idea of how depth first search goes. But before any of that, I need to make sure I can actually set up a binary tree. I think I've got it with this node class right here. So first we need to set up a root, and root will be node.new. And we'll just give this a value of 1. Then I want to print out at root. And then here, I'll initialize tree. This will be binary tree.new. So when I run this test, it should print out the binary tree. The test tree. Yeah. Okay, did not do that. Maybe I have to call something out on it. Yeah, let's try that. Oh, setup might not be running because there are no tests. Nice, there we go. So left and right are nil for that. And at tree dot left equals 2. Oh, that needs to be. Oh, sorry. This is in the wrong spot. Here. Oh, this gets weird, huh? Root dot left equals node dot new 2. Right. 3. Yeah, that looks right. Okay, cool. I have a binary tree. Now let me see if I can take this and set it up. Here. And I want to Looks like that works. Just make sure. Yeah, okay, cool. So now I can build trees that I can run operations on. Now, let me just see if I can print it out in level order or breadth first order. Okay. So I pulled this code from Geeks for Geeks. It's kind of the site that I'm using to go through some of this data structures and algorithm stuff. Pull the Python code. Yep, we've got a node. Print given level, root level. What is this actually doing? All nodes at a given level. The other is to print level order recursive. That's all I want to do is print level order. But we've also got this leaf node. All right, I guess I'll implement this and see what's happening. Right. Okay, so this will take the root, is great, and age equals height of root. Aha. Okay, so this height function seems to be what this operates off of. First node is none. Node dot no. Okay. Oh, there's an else. That's fine. I can just return this. Return to 0. This is a bit of recursion. No dot left. Right. This looks super similar to depth first search. So left height greater than right height. Return null height plus 1. If it's not, return right height plus 1. What does it say it does? Compute the height of a tree. The number of nodes along the longest path from the root node down to the farthest leaf node. Okay. Now I need to actually do this print given level. Given level, just take root and level. And return if root is nil. Level is 1, then I don't know what that print means. So I think what I wanted to do is puts root dot value. Right, that's what yep, value. Oh, this is weird. It's good that I'm looking at Python code though. Oh, I'm not too familiar with it. And then more recursion. Level is greater than 1. I want to do left first, and then level minus 1. Yep, same thing, just on the right side. Okay, so breadth first print of our tree. I was just going to print it out, so I'm not really going to write a test for this. One, two, three. Look at that. Nice. That's what I wanted to see. Not super sure. All right, let's see. Oh, so it finds the height to start out with, and then builds the loop. It prints it, and then it loops over. Right, so height is only used here. Okay. Yeah, this is weird. So I think it uses depth first search to figure out the height, and then it knows the depth, so then it prints a given level. Yeah, weird. Huh. Alright. Hey there, if you're just joining, I'm working on binary trees and using some stuff on Geeks for Geeks that I've found. Their first binary level order binary tree traversal was to do this print function. I got it working. Yep. 1, 2, 3. Now the next one, I think, yeah, using a queue. This is the one that I was curious about. For each node, the first node is visited, and then its child nodes are put in a first in, first out queue. Okay. Print level order. Create an empty queue. Temp node equals root. Start from root. Loop while temp node is not null. Okay. DQ node queue. Alright, I'm going to try doing this just off of these instructions. Yeah, I'll remove the stuff. QU equals a new array. Oops. Yep. And I'll just use an array for a queue and just shift to DQ and pop to, or push to enqueue. Right, I'll need a temp equal to root, which is fine. And then while temp is not nil, I want to print temp dot value. So the first one never. Okay. Yeah. So the root never gets enqueued. So I want to queue dot push. Root dot left. And root dot right. Oh, this is cool. And then temp equals q dot shift. What? Oh, that's so cool. And I think that's it. I did set up a test. Yeah, make sure it's called the right thing. Breadth first print. Yep. It's where I initialized the binary tree class with that breadth first print in it. I also implemented a node class at the top of that tree, to where when it gets initialized, it's got a value, a left and a right. Don't have to worry about types in Ruby, at least this version of Ruby. I set up a really small node. I do think I want to make that bigger though. Equals 4. Equals 5. Cool. And now it should print. Oh geez. I broke something. Go back here, and it's just alternating 2 3 2 3 2 3 2 3. Okay. I want to print out at root. Oh, it'll never get there. Dang. There it is. Get a little laggy. Uh-oh. Beach ball's not a good sign. Alright. Power through. See if my little laptop can take it. Alright. Temp equals q dot shift. I'll just do, well, this is less than 4, and make I equals 0, and then increment I, just to get some information. Oh, and I want to print what is actually getting shifted here. I know what I'm doing. I messed this up, right? Ruby shift. Oh no, it removes the first element. Okay. Okay, so it printed out. Huh. So now let's print Q. And see what's happening there. Doesn't seem right. Okay, saved. Ah, yep, makes sense. Not actually calling it. Oof. Hmm. Print no data and Q-tip knows children. First left, then right. And then DQ a node from Q. Two, three, two, three. Well, I don't like that. My temp is getting reset to root somehow. Okay, let's go look at their implementation, see if I'm missing something. Check out Python. Yep, they're setting up a node. Create a queue, queue.append. Oh, they in queue to start with. They're popping the front off. array. Oh. Okay. One, two, three, two. Why'd you go back to two? Cause I am silly. That's why. This needs to be tipped, not left and right. And now it should work totally fine. Oh, yeah, let me rewind. Because that was my original problem. Hey. Ah. Love it. Love it. All right. Iterative. I'm going to push these to the answer array. That way I can tell it, test it. Ah. Hoping for a green dot. And we got a fail. Oh. You know, should probably return that answer array. Sweet. That's pretty awesome. Green dot, green dot, green dot, green dot, green dot. Yay! Cool. That was a bit more straightforward than I expected it to be. Oh, let's see if I can remember depth first search. I think I remember the recursive version. Okay, and I think it is like root dot left and root dot right. I want to check if root dot left is not nil. Same for root dot right. Ooh, let's do this a more Ruby way. Use less. Need to make sure this is root dot right. And let's just print root value. Need to set up tests. Well, this test should fail, which is okay. I just wanted to print stuff out. Four, 2, 5, 1, 3, I think is right. Let's see if I can make sense of that. The one at the top, and then 2, 3, and then 4, 5. So 4, 2, 5, 1, 3. 4, 2, 5, 1, 3 is correct. I have, oh right, there's like these pre and post orders. Yeah. One, two. Oh, so this is what I have. 4, 2, 5, 1, 3. Oh, so I did an in-order traversal. Okay. In order. make an answer array so I can test it. And then answer dot push root dot value. And this is 4, 2, 5, 1, 3. I've been muted forever. It's fine. It's fine. Okay. Yeah, that's exactly what I wanted to see. So that was in order. I believe if we were to visit the root, Yeah, so in order, pre-order, and post-order all change where we do something with the root. One, two, four, five, three. Yep. So then to get pre-order, I think that's what happens. Let's see. The test will fail, which is fine. 1, 2, 4, 5, 3. Yep, that's it. Okay. And then post order, it'll be 4, 5, 2, 3, 1. Four, 5, 2, 3, 1. Awesome. Now that my mic's working, if you're hanging out and watching, feel free to say hello in chat or drop a follow. Yeah, either way, it's all good. Hanging out and learning about binary trees. Oh no, this will be array dot this pre-order push root dot value, and then I want to recurse on root dot left, pass in the array, and then I don't want to do that if root dot left is nil. I'm going to do the same thing on the right side. Oh, and then I need to return my array, which is good. And then let's do post order. Depth first, post order, array equals array. And then depth first, post order, pass in root dot left, array, and only do that if root dot left isn't nil. And then I can do my operations. Array dot push root dot value. Oh yeah, I don't think I need that. I like it though. And then I'll return the array. Okay, so let's write some tests for these. Pre-order. All right, I actually need to call pre-order. And then post-order test. Okay, so pre-order is printing it out first. It's supposed to be something like we hit 1 first, then 2, 4, 5, 3. This one will be 1, 2, 4, 5, 3. And then post order, it's doing all the stuff. It's recursing. That one makes less sense. Let's go back here. Pre-order 1, 2, 4, 5, 3. Yep, okay, that makes sense. Post order is 4, 5, 2, 3, 1. Okay, so 4, 5, 2, 3, 1. Okay, that makes sense. 4, 2, 3, 1. Okay. Hopefully these pre-order and post-order tests will work. Yeah, nice. Okay, that's awesome. Cool. In order tree traversal without recursion, that's what I wanted. Using a stack is the obvious way to traverse a tree without recursion. You know, they say that. I don't see it. Okay, create an empty stack. Initialize the current node as root. Push the current node to the stack and set current equal to current.left until current is null. Current is null and the stack is not empty, then pop the item from the stack, print the popped item. Whoa. Alright, it's blowing my mind a little bit. Okay. So it traverses all the way down the left. Oh, this is cool. Then as soon as current is null, so that would be effectively current.left is null, and the stack is not empty, then pop the top item, print it, and then set current equal to popped item right. And then go to step 3. Yeah, that's awesome. Okay. Oof. I'm excited about this, but it is time to call it. So let me get in status. Okay. Want to add all of this. This will be fun to review tomorrow. And binary, oh, the lag. I need to figure this out. Tree, oh gosh, it's getting worse. Oh gosh. Breadth first and depth first. Traversals. Okay, we got it. Oh, hey, stranger in the night. You caught me finishing up again. You don't like me? That's not true at all. I've enjoyed our conversations thus far, especially the one about the dream. That was particularly good. It's just timing. It's bad timing. If you notice the little beach ball that keeps spinning there, like my laptop's getting a little angry at me. And I'm trying to finish up, if it'll let me. Okay, I updated. Let's go to the README. Yeah. Yeah, and I'm always happy for you to pop in. I thought it was the morning, then half hour later realized it was 8 p.m. Some days it's like that. Some days it's like that. Iterative. That's what I was trying to think of. Iterative. Yeah, Stranger of the Night. I'll be streaming a little bit earlier tomorrow because I've got some plans in the evening. Probably around 3 o'clock Eastern time, which will probably be, what is it, a 4 hours difference here in British Columbia? 11 or 12, something like that for you? Noon, okay, 3 hours difference. Yeah, and I'll be going over what I did today. I was having some fun with binary trees and figuring out different traversals of those, if you're into it. Is this Ruby on Rails? No, this is just plain Ruby. No Rails involved whatsoever. I use Ruby on Rails at work every day, and decided to use Ruby, just plain Ruby, to kind of see what the difference was for this 100 Days of Code challenge. Oh, I need the breadth first link. What do you create mostly with Ruby? I haven't really used Ruby for a lot of side projects. I use it at work. We make auctioneering software. So what I mostly create is that. But for side projects, it's been all of these data structure and algorithms problems. My plan is probably the second half of this 100 Days of Code challenge actually start using Rails and creating web apps and whatnot. Okay. Is Ruby mostly used for backend development? I think no is the short answer. With Rails, Ruby has a front-end templating system, so it'll generate the HTML on the server and then send that to the front end. The way we use it at work, we do use it for back-end development. So we set up a Ruby on Rails just API. So you make a call to a website and then get a bunch of data back, but no HTML. And then we use React on the front end to parse that data. And React is a JavaScript framework, if you've heard of it. Yeah, the big sell for Ruby on Rails is I've been researching, so I understand you now. Nice, nice. That's awesome. That's awesome. The big sell for Ruby and Rails especially is building things fast. Rails specifically makes a lot of decisions for you as a framework. So it's very opinionated. So as long as you abide by all of those opinions and rules set with Rails, you can build things really quickly, which is the hope for later in my 100 days of code. All right. Day 10 is done. 10% there. And it's time to call it. By the end, you'll learn a bunch. That's the hope. That's the hope. Stranger of the Night, thanks again for stopping in. This is where I leave you. Hopefully I'll see you later.